the one. Why am I thinking arc sine and not normal u sub? Why does normal u sub not work on this one? I have no x on top, right? It's just a number on top. If I just have a number on top, or if I don't have enough x's, it's probably arctrig. But is this written in an arctrig way to begin with? So therefore, what do we have to do? Think about which one it's closest to and make it match. What did I do in order to accomplish that? I went ahead and saw my x squared. I figured he should go before the x term, so I reoriented how they looked. I pulled out the negative because I need a squared minus b squared. So adding the 1 on the outside, which was really a negative, needed to offset with adding a 1 on the outside. Then I was able to get it in my nice form that I'm ready to basically go ahead and solve with, right? Because from here, kiddos, who's my A? A equals 3. Who's my U? Who's my DU? Now carefully plug in. Carefully plug in. You can go ahead and say this is the integral from, of 1 over square root of, do I have my a squared minus u squared? Yes. Dx can be replaced with du. Do I need to pull any constants out? No. So let's just jump to the answer, okay? And the answer is 1 over a, which is 1 over arc sine of u over a plus c. Now wait. When we go looking at the A, B, C, D, E, we say, uh-oh. Well, hold on. Some of you would quickly look at A and say, yay, he's right. Except number 1, why is he obviously not right? It has an arc secant instead. You have to be careful. They might try to throw us off with the arc secant. Then I know Brandon, hold on. I think what you're thinking is what I'm thinking. Letter C. Looks an awful lot like it, but what's missing? Oh, so duh, it must be E. Unless you memorized your rule wrong. How does arc sine's rule go?
There's no 1 over.
There's nothing in front. Just be careful. Just be careful. Some of you have gotten so into the habit of 1 over A, you do it all the time. So make sure that you know those rules. Because if you don't go into the test knowing your rules, it's going to be a guessing game half the time. We don't like those. Final answer, C was right. Just be careful. It might try to trick you, and as you can see, letter A, some of you would have circled, and letter E, some of you would have circled. C is the only question. Questions on this one? Why was he tricky? Yeah, we had to complete the square, right? Now let's go ahead and just take 1 second to go back to those questions that you guys had, 61, 39, and 45. Can you guys help me out real fast? And let's see what these problems are starting at the lowest. We're not going to solve all of them right this second, but first of all, what integral is number 39? Oh. Does this match what we just did? No. All right, so let's not worry about him. Let me add another page for number 45. You guys have 45's problem ready? Okay, who is he?
Y equals 2 over x. Y equals 0.
Now this does not tell me how to solve. Should you put it in context, I bet we know. What does it ask us to find? Technically, what's it ask us to find? Find the area of the region bounded by these curves. But Alan was right. If we're trying to find the area, we're going to have to set up an integral. We'll come back to that one. That also doesn't match. How about number 61? I'm just seeing if any of your questions match up with the tricky ones we're doing. The 61's problem. Like that?
No, the x plus 1 is squared.
Like that?
Yeah.
Ew. Do they use brackets or something?
No, they just put the parentheses around.
X plus one.
one.
So it's x, so they don't put it around the original x plus 1 like this?
Yeah.
Oh. Oh, well you guys aren't asking any arc trig. Okay, never mind. Maybe we're getting the hang of it. Did we get it right? Arc sine of x minus 1 over 3 plus c. Got it, check. Okay, let's do one more. And then we'll go back to the questions. Actually, I think we have 2 more. Okay, kiddos, hopefully this one seems kind of nice compared to the last one. Yeah, it's totally arcsecant, right? But with arcsecant, if you don't know the rule, you're sunk. If you know the rule, maybe we got this. Question, who's A?
One.
Remember? You have to think about, it's the integral of u squared root of u squared minus a squared, true? And then we have our over 1 and then du. So who's our u?
2x.
Who is being squared? 2x is being squared. Du is equal to? Some of you have gotten into a rhythm. Just be careful it's not the wrong rhythm. Since we have the 2 dx, we do need to go ahead and say dx is equal to du over 2 when we go to plug and chug, yeah? Okay. So let's take our little integral right here. Let's bring him down. We can rewrite him as the integral of u square root of, wait, yeah, that's u, right? Okay, that matches. If it didn't match, we might have a little bit of trouble in our hands. If it didn't match and there was just an x, we could go ahead and say x is u over 2, just a little heads up. We have our u squared minus a squared times du over 2. What do we do with that over 2, cool kids?
What out?
That's the way. And then, what do I do to the rest of it? Pull out the 1/2. This guy's gone. I pulled him out. How's the arcsecant formula go?
1 over a.
1 over a.
Absolute value.
Absolute value. Remember we changed that rule? Of u over a plus c. And we end up with D. No, read carefully. Who is it?
A.
Right? The arcsecant formula, arcsecant has absolute value. We talked about it in class, and I just fixed it in the first one. If anybody else needs to change the absolute value for arcsecant, do so now. Don't wait, you might forget. Arcsecant is the only one that has an absolute value. Arcsecant, arctangent are the only ones that have 1 over a. Make sure you have it. Do we get it? 1/2 arcsecant of 2x. Check. Ooh. What about this guy? Ready, set? You guys, go all the way. I'm going to freeze the screen and do it and then show you what I get, but you guys, go for it. If you're watching the video, pause it and do it. Otherwise, you're going to see me do all the work for you. I think. Careful, one of the easiest mistakes to make is the coefficient.
square.
Now,
Oh, okay.
you see it? One reason I wanted to show this one to you guys is there's an x on top. So some of you might have thought that the whole denominator equals to u, and that would have been a valid thought. Usually when there are variables up on top, we can set the whole bottom equal to u, but it wouldn't have worked out. You would have tried and tried and tried, it wouldn't have worked out. It doesn't have enough x's up top. So be on the lookout for an arc trig, even if there's an x on top. And in this case, we would have had to ask ourselves for a, who is squared? 6 is squared to be 36. And then for u, who is squared to be x to the 4th? X squared is squared. Does that make sense? This was kind of hidden. Not as hidden as the complete the square ones, but still kind of hidden. You have to be careful with your substitution. Be careful with your formula. Plug it in, plug it in. Did you guys notice the difference in the multiple choice answers? The only difference is the constant. Oh man. Gotta make sure we have that constant right. Questions on this one? You all right?
Did you say, how did you write it as
U squared. So look at the x to the 4th as somebody squared. Who squared? Must have been x squared squared. Does that make sense? Any other questions? No? Okay. Remember our formula for arctangent is 1 over a. Our a is up on top. 1 over a arctan of u over a plus c. Technically, if any of you guys are wondering, couldn't the c have happened here?
No.
It could have. But why do we still write the answer as this one? What happens when you bring in the 1/2? Yeah, and 1/2 times c can just be a new c, so we just keep it as a plus c. But also start doing things like c1 and c2 and blah, blah, blah. That's yucky. So we just kind of ignore that stuff. So we could have done it that way, if that would help. If any of you guys were thinking or did that until the okay. I think we have one more. We got it. 1/12 arctan of x squared over 6. We already did the heart method one, and we finished that one. Here's our. Oh no, we finished. We finished.
Yeah.
Go team. I just have an extra page of who knows what. Let's go back to those ones you got stuck on then. Those ones weren't even arc trig. This is from earlier in the chapter. This is a tricky U sub one. Or is it? Oh, it's okay, it's okay, it's okay. I know you hate exponents. There is no product rule for integration, right guys? So I am not allowed to do this unless I make it a single power or I multiply. But when I multiply, it doesn't really simplify. But how can I rewrite him? I can think about it as x to the 1 times x to the 1/2, right? Can I combine those since they have like bases? It's going to be x to the what? 1.5. Remember, like bases, you add the exponents, so 1.5 becomes 3/2. Ooh, yeah, he was hiding from us, but now we got him in our sights, right? What rule do we have to use? FTC, but in order to do FTC, we got to anti-derive first, right? We got to do this integral. Some of you watch your notation. 3/2 becomes, when we up it by 1, 5/2. We multiply by the reciprocal, 2/5. And then we write the 4 to the 9 to symbolize we still have to do f of b minus f of a. Is that okay? Now we plug and chug. We can pull the 2/5 out because he's for everybody. And we can say 9 to the 5/2 minus 4 to the 5/2. Remember, you always plug in who first? Yep, plug in b first, then we plug in a. F of b minus f of a. Now some of you are like, box it and you're done? If it's a long answer, yeah, box it and you're done. I don't mind. If it's not a long answer, stink. What does this actually stand for? or represent? Ooh, you could start raising really, really high powers, or you could just do something spiffy like, wait, 5.5, isn't that 9 to the 2.5? Oh, that looks nifty. Right? Isn't 5 halves 2.5? So 9 squared times the square root of 9. Or if you don't like that notation, couldn't you also say, and this is what I'm showing my algebra kids right now, is it 9 3 squared? And what's 2 times 5 halves? 3 to the 5th. Maybe that's a little bit too crazy for us. So if you like it a little bit better. 9 to the 5 halves. If you don't want to think about the square root of 9 to the 5th, that's messy, that's yucky. And that's not very mental math. You could go ahead and think of it as 9 to the 2 and a half minus 4 to the 2 and a half. Why am I showing you that? Guys, what's the square root of 3? Or 9? 3. What's the square root of 4? 2. 9 squared is 81. 81 times 3 is 243. Minus 4 squared is 16. 16 times 2 is 32. I'm just showing this isn't as much of a needing of a calculator problem as you would think. 243 minus 32 ends up being what? 211?
Yeah. Times 2.
211 times 2 would be 422?
Over 5.
Got it. Dun, 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 dun. If it's a long answer, don't you dare go beyond that. Stop there. Don't make any mistakes with the simplifying. But if it's a multiple choice, they probably will have the 422 over 5. And it'll probably be a non-calculator problem. Yeah. It's the same thing. The problem is that this was a non-calculator problem, because if it was calculator, we'd just plug it in, right? We wouldn't solve it. We'd just plug it in our calculator. If it was a non-calculator problem, I don't want to raise 9 to the 5th. You know what I mean? So then I was trying to do it a different way, but it is the same thing. Yeah. All right. You guys have a question on number 45. Define the area under the curve. What is going on in this picture? Hold on. Don't we basically have this and this? And then they tell us, okay, cut it off at y equals 0, cut it off at x equals not 0. X equals 1 and x equals 3, and then take the graph, whatever's in between, which will be something like this. They're asking us to find this area, where we have the function y equals 2 over x. We have x equals 1 here. We have x equals 3 here. And we have, technically, y equals 0 here. Well, guys, what finds us this area right here? Integration. What are my bounds going to be? 1 to 3. What's my function going to be? Do I have to worry about anybody else? Nope, I got it. But wait, they gave us, doesn't matter. That just cut it off down here. And that's what an integral does. It cuts it off down there at y equals 0. So then all we have to do is say, I think this is a rule. Is this a rule? If you don't notice it, pull out the 2. Now is it a rule? Mm-hmm. Yep. Who has, or who is the antiderivative of 1 over x? You got it. ln of absolute value of x, and what are my bounds? 1 to 3. So can't I pull out the nifty-difty 2 and say ln absolute value of 3 is 3, minus ln of absolute value of 1 is 1? But they didn't have that as their answer. The correct answer is going to be ln of 9. Wait, what? We'll see if we can get there after Bridget's question. Exactly. So we could go ahead and say that's just 0. Then we could rewrite this as 2 ln of 3. And then we can bring the 2 up. Right? So ln of 3 squared is 9. Dun, 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 dun. Now, they could have written 2 ln 3, I don't know, whatever the back of the book said. Did anybody check it? Was it 2 ln 3 or was it ln 9? See? They're simplifying. Is that okay? Okay. Last one. Oh, sorry, do you have a question?
Oh, no.
Okay. Oh no, this is one of the most commonly forgotten integration rules ever. Oops. Ever. There we go. Who do you guys see? I see a b to the u or an a to the u or an a to the x or however we wrote it. What is the integral? Bless you. Of b to the u du.
1 over ln of b.
That or that in some form is the forever. Maybe it's the integral of a to the x dx is 1 over ln of a times a to the x. I don't know. There's different ways of writing it. It's the same thing. Who's my u?
X plus 1 squared.
Oh yeah. U is equal to. Now some of you are forgetting how to take derivatives and it's okay, I understand. But let's review. Doesn't this guy need a chain rule?
Yeah.
Derivative of the outside, what do we do?
2x plus 1.
Times. Now in this one it's just times 1, so we're okay, dx. But if this was a 2x, this would be times a 2 and it would throw off our answer, right? Just be careful. Now we solve for dx just like we always do. Yeah.
Why did you make it x plus 1 squared?
Because I'm thinking about this rule over to the side, and I'm thinking about who is the power, because I usually make that the u. Remember how, like, with e to the u, we just choose whoever's in the u spot? Same thing with b to the u. So now I have b to the x equals, it's time to plug and chug. Integral of x plus 1, I don't know, whatever, he's there. 5 to the, who did I make his whole power?
Yeah.
I like it, because that matches my formula, right? My u looks kind of ugly though, so let me make it a better u. For dx, I can plug in du over 2 times x plus 1. Is it legal for me to cross out the x plus 1s? Yes. Because there's only multiplication. Factor on top, factor on bottom. What do I do with the little 2?
Take it out.
Pull them out, pull them out. So I have 1/2. Bless you. Integral of 5 to the u du. Use your formula. How do I get there?
1/2. 1 over ln of 5.
Times.
5 here. Or 5.
And then I'm going to plug in my x stuff, right? So 1 over 2 ln of 5. 5 to the who's u?
X plus 1 squared.
Plus c. Is that good? Sure. Is there another way of writing it?
Yeah.
Sure. How else could you have written it?
1 over ln of 25.
Yeah. Remember, you could pull that 2 up. What did the back of the book have? Had 25? Oh, okay. So in the back of the book this time they kept 2 ln 5. Okay, sometimes they can. But they could have also made it ln of 25. Just depends on how they're feeling, I suppose. Yeah. Did anybody find any extra problems or additional problems that they found when they were going through?
81.
81? Let's go check them out. Don't worry, I have a plethora of problems in my head if we need someone. It's the second time. What's 81, Ryan?
Integral of 1 over e to the 2x.
Ooh.
Still in the denominator plus e to the negative 2x.
Yes.
dx.
Okay. This one's a party waiting to happen. I think I've helped a couple people on this already. I was only of the ones who started it early. Alright, let's problem solve. I don't want to just tell you the answer. You won't have me tomorrow. I mean, you will, but not able to give you answers. Why should we or shouldn't we make that u? Katrina's saying e to the negative 2x. Maybe he doesn't belong there. Maybe he's supposed to flip somehow. That's an idea. Another idea is if we actually were to do this, guys, what is this going to make really, 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 really awful?
2e to 2x.
Right? I'm not sure that's really going to help us if we just have a 1 up top, right? So when I have a constant over something yucky, maybe it's an arc trig? No, it's not an arc trig. Okay, let's try to use Katrina's hint. She said, hey, this guy, we can rewrite him. And can we? Yes, but how? You gotta do it legally. With that addition down there, this is tied. We can't randomly go popping people up to the top, but what we can do is rewrite him how he's supposed to look. That didn't help anybody. Yes, it did. Wait, what? How do we simplify complex fractions? How do we simplify complex fractions? Multiply top and bottom by the yucky guy? He's not yucky, he just needs to be moved. Yeah, maybe we shouldn't judge him so much. On top we have e to the 2x, right? On bottom, what do we have? E to the plus e to the 2x, e to the 2x, add them, 2x plus 2x is 4x. What happens when I bring them in the second one? Now, some of you are like, okay, we have stuff up top, let's make that whole thing u. But if we do make that whole thing u, what is still not going to be quite what we hope him to be? Yeah, before e to the 4x dx. Question, is that going to help us when we have this guy? So once again, we try to use sub, and all we get is basically what amounts to a not working again. So we say, well, that's not the right way to go. So what is the right way to go? Arctangent. Arctangent. You guys see the arctangent? I see a u squared plus an a squared if we do it right. A is equal to 1. U is equal to, what do you guys think? Who's squared?
U 2x.
Exactly. And why do I like that? Because who would u be? Don't forget your bunny. U prime. Right? E to the u times u prime. Solve for dx. Dx is equal to du over 2e to the 2x. Now we plug and chug. We have e to the 2x over u squared plus a squared times du over 2e to the 2x. Booyah! Who's going away? Calculator. It happens all the time. What do we do with that over 2?
Pull it out.
Pull it out. When I pull it out, guess what's going to happen? I just have arctan, right? So I can go ahead and say 1 over a, because arctan does that, not arctan. Arctan or tangent inverse, they're the same thing of u over a. 1 half arctan of e to the 2x plus, 2x. Dun, 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 dun. Okay. I'll take one more question if someone has it. Otherwise, I'm just going to do some random, simple, and yet tricky problems just to get us ready for tomorrow. Sure. 69. Okay, number 69. Bridget, sorry, what is it, kid?
2, 5, interval 0 to 1, parentheses, y plus 1, close parentheses, and square root of 1 minus y dy.
Good example. It's not arcane. It's not any of the art stuff. It's not over. There's no product rule for integration, right, guys? So I can't do that. So then we say, okay, let's multiply. Is that gonna make anything better? No. So we better say, well, let's try a U sub and hope something gets better. All right. What do you guys think U would be?
1 minus y.
Oh yeah. Du is equal to, you guys get negative dy. Okay. So we can move the negative to the other side to get dy alone. But do we have enough to plug and tug right now? So what are we going to do? If you don't have enough, that's okay. Go solve for y. Add y, subtract. I think we get 1 minus u. Anybody tracking on that one? Let's see if that helps. We're going to have 2 pi times the integral. Wait. We're about to go to u's. Now you could ignore the bounds and bring them in later once you go back to y's from u's. Or you could say, who is u of 1 and u of 0? Going back to u, plugging in 1. 1 minus 1 is 0. 1 minus 0 is 1. Basically, I was just trying to write my integral, and I'm like, oh wait, if I'm going to use, I can't plug in 0 and 1. That's kind of illegal. So I could just leave it off and go through my process and get my antiderivative, and then go back to y's and then come back to 0 to 1. Or you can change your bounds to u bounds. Because when I go plug it in, y is equal to 1 minus u plus 1 times the square root of u du. Everything's u's, and I'm like, hey, I want u's in my bounds also. Does that make sense? So I'm going to use, I'm going to use, I'm going to use. So I say, hey, I want some u's there too. Or just don't write the bounds. Get the antiderivative with like the y's, get back to the y's, and plug in the old bounds.
Oh, so you can still do. Okay.
Okay, so now we end up with, now can I, well, wait. 1 plus 1 is, okay, we can change that a little bit. Oh, it's a product again, I failed. No, I don't. Hold on, my writing of my bounds failed some. Question. Can I multiply this now?
Yeah.
So now I get 2u to the 1 half minus u to the 3 halves, 1 1/2. Oh, did I not put my negative in there? Look at you catching my mistake. Did anybody else catch the negative mistake? Oh, I flipped it again. My silly bounds. Why are they the same numbers? Now, if you guys don't like the 1 on bottom and the 0 on top, what can you do? Yeah, you can flip them back if you want. I'm just going to keep them that way so people don't get confused and think I'm just using the old bounds and the negative just disappeared. What's it time for me to do now?
Split about and solving.
It's time to antiderive. Right? It's time to antiderive. So I have u to the 3 halves times 2/3 times 2 would be 4/3 minus u to the 5 halves times 2/5 from 1 to 0. The nice thing is, since I switched my bounds, I am allowed to plug them in for the u's. I don't have to go back to the y's. If you skip that step, you could go back to the y's right now and then plug in the old bounds. Either way works. I'm going to go ahead and just start plugging so I get negative 2 pi 4/3 of 0 to the 3 halves. But some of you are like, isn't that just 0? Yep. We'll get there. Minus negative 2 pi, which would be a plus 2 pi.
Oh, because you did the use before, you can just.
Exactly. So that's the benefit of it. You can just plug it in and not have to go back. So one time I would say maybe don't do that is whenever you do the arctangent and stuff, we're so used to going back to x's, just don't change it to u's. If that makes sense.
But you can do that on other ones.
Uh-huh.
Not the
All
one.
other ones. Yeah. I have 3 halves. Minus 2/5. 1 to the 5 halves. Kiddos, what's 1 to any power? Mm-hmm. All this is 0, right? 0 minus 0 times anything is 0. I get 2 pi times 1 to the 3 halves is just times 1. 1 to the 5 halves is just times 1. So I end up with 4/3 minus 2/5. If it's a long answer, box it. But technically, if it's a long answer, you could box it right here and say, whatever, I'm right. But if it's a multiple choice, what for sure are they going to do? Yeah, they're going to get common denominators. 5/5, 3/3. Maybe they did other stuff in between, but what else? We have 2 pi times 20/15 minus 6/15 would be 14/15. Final answer of 28 pi over 15. You guys double check my math though, right? Someone's back in the
How'd you get 1? Okay, so you have
Here.
plus, yeah.
1 to any power is still 1.
Oh, yeah, yeah.
That's the nice thing with 1. If it was something else, we'd be in trouble. Okay, so we have about 5 minutes left. I just want to, if I were you guys, open up your notes and let's go back to the big idea problems. Let's do some simple ones. We did some really hard big idea problems. Let's do some simple ones. Meaning, quick and easy to mess up.
You want us to permanently push them out?
Yeah, I just did. Or you could do after school. Or lunch. Lunch is fine. No, I'm gonna just collect the packet tomorrow. So on the front table there'll be an integrals and that change pile, just for the problems that we talked about. A notes pile and a homework spiral pile.
Everything is that 1 to 11 minus 16.
Yes. We didn't go over 11. Just hold on to your packet tomorrow. We'll go over it on Tuesday real quick and make sure you guys are okay on 11. Yeah, I didn't want to. Yeah, we'll just. Alright, cool kids. Let's do a few more examples. Ready? Let's see what you can do with extra practice. Practice makes perfect as long as you know your formulas. If you don't know your formulas, do that first. The integral of sine of 3x dx. The integral of 1 over e to the 5x. The integral of our goal right now is not to get all of these done. Our goal right now is to know if we know how to start. My question on A, because we don't have time to solve them all, not right this second. My question on A, is the answer negative cosine of 3x plus c?
No.
No! Why not? Because there is a u. So you would need to go through your process, right? Don't kill any bunnies. Final answer should be 1/3, negative 1/3 cosine of 3x plus c. For letter B, ln? Nope. Rewrite. If you just have a 1 over e to the, we can always make it e to the negative. And why does that make life so much better?
Fractions are.
Fractions are hard, but if I have e to the u, kiddos, all I have to do is what? Yeah, u is equal to negative 5x. du is equal to negative 5 dx. I'm just going to do a dot, dot, dot. You're going to end up with negative 1/5 e to the negative 5x plus c. And letter C and D I definitely cannot solve right now. But what we can do is at least figure out how to set it up. Letter C, heart method, except U. So that just improper fraction. If it's not an easy heart method, what can we still do if the top wins or ties? What can we always do first to make it easier? Divide. Letter D. U sub, because there's an X on top. But wait. No. What are we going to do instead? Here's a nasty heart method that's a really good idea. Because then over here with 2x over, I can use U sub. And over here I can use arc sine. Alright, cool kids, you have more practice in your review, you have more problems in review I didn't assign. Peek over integration does not change what we have done, so don't stress too much, and I'll see you tomorrow. Make sure you know to do these 4 also. Just trying to give you good practice.
Can I come in with the sheet?
We'll say this last week, we cancel alternative worksheet.